Hello everyone, welcome to Codex Tech, Rust Learning video blog. This is part 2 of Superhero app, and in this part we will cover the backend web API part, and I will be using Axum to create our web API in Rust. Um, and I will, as usual, all the links, including the any reference material as well as the source code link will be in the video description below. And please watch the previous part one of this series to see the web UI part that was built using Dioxus. So yeah, in that part we already saw briefly how the UI looks like and the functionalities, and also I showed the MongoDB interface and the data in there. So let's just jump into the code part. Um, so one thing for sure that I created both these projects in separate folders, um, but I have seen some new. Uh, I mean, new for me. I don't know how old that workspaces concept is, but in Rust we can create workspaces. So both the API and the UI code could be part of the same project or folder, and then write some script to execute and run them. I'm planning to use that option for the next video series that I will create, where I will combine, I think, these concepts like creating a workspace. We have a UI in the backend, and I'm thinking about creating more end-to-end finish project in that one because now I have covered both the UI and the API. Um, and it will be a good learning experience. I'm not sure how it's going to go because I'm not still as experienced with the Rust programming language. So anyway, so let's jump into this API project. So in this API project, of course, we are using Axum. So this is the crate that is like a web framework in Rust. There are a bunch of other frameworks. Tokyo, I believe Tokyo, yeah, Tokyo is very popular. There is Rocket. I have used Rocket before, um, but I haven't used other frameworks. XM is the other new one that I think I used Tide as well in one of my previous videos. But Axum seems to have more momentum and a lot more features are coming in and they keep giving new updates. So that's why I decided to go with Axum. I think Axum is part of the Tokyo. So Tokyo, I am trying to remember. There was another framework that is very popular. But anyways, Axum is used. This JSON crate is used. It's like a JSON format, but for MongoDB. So data that we'll be saving and retrieving from Mongo, it requires this crate, and you will see there's a document macro available in there as well. And I'm using this dot environment, so that is just to store the um, MongoDB configuration information, so it's not in the source code. Next important one is MongoDB, and since XM is part of Tokyo, so we have to include Tokyo as well. And Axum is built on top of some existing web framework. There was one Tower. It was a precursor. So Axum can use any middleware that were written in Tower. So we have to include Tower, and we are including the course features, cross origin request. I'll show that one soon in the code as well. So let's let's look at some code now. So we have cargo. Environment is not important. Let's jump into the source. So before we look at the code, there are three, I will call them DTO, data transfer objects. Um, and that will be the plan for some future series where I will try to use the clean architecture, so some of domain-driven design or clean architecture concepts, building APIs in the UI. In general, like this comic and superhero response. So superhero response in this case is a DTO, and this superhero and comic is more like a domain model or the model that will mimic how the database or the database collections are created. So comics or comic we can see is ID and the name. Um, as in the last end of last video, I was showing the MongoDB. So in the comic collection, we are uh, storing ID as a string, and we are providing this value. It is stores underscore ID, like the key column. In Mongo, we are not using the object ID for this one. But if I look at the superhero, um, superhero.rs, so in that one, um, first of all, we are using the serialize, deserialize from Sarday. And then I have these fields like ID, first name, last name, hero name, and comic ID. That is in the actual MongoDB collection. So it is just reflecting all of them as is, and ID is option object ID. So if I provide null, as you can see on this line number 7, if I provide none value, then it will skip the serializing it, and MongoDB will auto generate the ID on the server side, which is what we want in this case. So it will create a unique ID, and we are providing all the other values. And that was the reason when we sent from the UI, although I was sending some value, but I was sending in a string, so it will not uh, deserialize to this object when we receive it, and it will not save. So that's that one. And the last one is, as we say, a DTO, data transfer object. So whole purpose of this object is to transfer the data. So it's not there is no one-to-one mapping between this one and the database collection, but it is what the client is expecting on our web UI. So we have same like ID, first name, last name, but differences we have here a comic object. So we are using MongoDB reference collection concept. So we are not storing the value directly in the same same table. So so what we do is that when we look up the data, and I'll go over that Mongo code in few minutes, we pull the comic collection information as well while we get the superhero based on the comic ID, and we populate this comic object, and then we return it to the UI. And this is how it would be like even for if it was a Finnish application, because I want to include comic name at least with the superhero. Maybe comic ID was not important. I could have just used a comic name, but either way, it will work. So next, let's look at the main. So starting from the top, let's see. Some using from Axum, we are getting some stuff from based on this is um, for MongoDB. I was using Future Crate initially, but then I decided not to use it. It was to get the data out from MongoDB. This is just one of the ways. But in my implementation, I didn't need it, so I think I have commented our code down below, so I did not remove the reference, but it's not really used. So some of the things that were listed above from Axum or Tower, I'll just cover now here. So first of all, environment. So we just read the environment file to load up configuration. In this case, that's the database name. I think it's the username and password. Sorry, not the database name, but username and password that is in the env file. Um, it will be at the bottom. So once we go to the helper method, it will be listed there. So we are creating few routes. So one is superhero route. So if base address slash superhero, it means we want to get all the hero that are in the database. If you provide a secret ID, then it will bring only that superhero. Secret ID in this case is the hero name, not the first or last name. I did not use ID to search for it, so I just call it secret ID. Add superhero is to add a new superhero. So first two are get. This is a post, and that's where on when I use the Axum on top for routing, I included delete, get, and post. And the last one is of course the delete. So all these three are all sorry, these four are the routes that we will be using. And then course. So from the tower middleware, tower HTTP, we are bringing cross origin requests, and the reason is because we are running our UI on different port 8081 and API is running on the 8080. So we have to allow this cross origin request, otherwise it will fail. So we are saying here that allow origin 8081. So that's what it is required, otherwise it's not going to work. And next, we are other important thing is about the methods. We want to allow post and delete. If we don't have this one listed here, we just say get, then it will throw an error. So yeah, this is the course layer, and this is simply we are starting up the Axum server, so port 8080, and we start listening on that port. Uh, let's Let's dive into app dot into make service. Yeah, so all this is so now the server is up and running. Next, let's see. So let's see. Where should we start? Maybe we should start at the bottom. So I'll go all the way to the bottom. Yeah, let's start with connect to MongoDB. So let's start from this function. So this is a helper method that I've created, and what it will do, it will create connection to MongoDB the Atlas. So it's a hosted and free service. And if you see in the environment file, I have these two variables, Mongo underscore user and Mongo underscore password. So once you create your account on the MongoDB Atlas website, you will get a unique user ID and password that you can save in your env file. And this will load that one and create the connection. And this is so after we create the Mongo connection string, we are calling client option.parse, and later we create the client object. This will be connecting us to the MongoDB. So Mongo connection, we provide the string, and then we loaded a client with options. So client object is created, and we return it from this method. One other thing, if you notice on line on the on line number 218 in the function definition, I'm returning result either it is a client object or it's a custom error. So I created this custom error object to leverage this question mark feature of Rust, like it unwraps the option or result, and if there is any error, it will throw the error. But I cannot just use a default like result object, and just using MongoDB object would have one issue that I cannot use the same for returning error from other places. So how I did this one is using this custom error struct. So there is another create, I believe any error in Rust that can be used, but I thought this scenario was very simple. I did not need to use any other external dependency. So just create this custom error structure, and we have it, like just using the MongoDB error in there as a value, and then we say uh, implement into response. So this is a requirement from Axum. So we'll have to implement this into response for our custom error. Otherwise, we cannot use question mark and return errors or propagate the errors from Axum web API methods. So I kept it pretty simple. If there is any error, I am just saying a status code not found. It's not very sophisticated. It could have been different options how you want to capture the status code, but I just said not found, and I returned the actual error response that was coming from this internal, let's say, MongoDB error. And other thing we have to do is we have to implement this uh, from method. So if the error is coming from MongoDB, we want to um, convert into the custom error. Otherwise, if you use a question mark, for instance, in the connect to MongoDB method where the error is coming up as MongoDB error, it will not know how to convert that MongoDB error to custom error. So this from method uh, will will convert that or transform that error to custom error, our custom error method, and that is supporting this into response from Axum. So that's why we are using custom error. And if I go up to, let's start with, all hero handlers. So everywhere I'm just returning this custom error. So in case of all heroes, we want to return all the data that is available. So we are just returning the vector of superheroes, and it's a superhero res or result. This will be the DTO, and custom error we are using the same thing. And here is now the interesting MongoDB part. So for MongoDB, there is a find method. We can use it if we had embedded comics inside the superhero. But since we are not using um, embedded collections or embedded data, that means I have to go to the comic collection and find the comic for the given ID from superhero and get that information. So this is what we are doing. So doc is a macro that is provided by MongoDB Rust driver. So we are saying that use the lookup feature, and we are looking from comics, and this local field is the name of column in the superhero table. So we are calling comic underscore ID, and foreign field is the name of the field that is in the comics table. So there's underscore ID, and we are saying just return it as comics. So this will be the name of the object, and then we are going further down, like how the response will be created. So since we are getting data from the superhero, but we want to include the comics in it, since it's not embedded, so but we are adding a field called comic in our response, and we are getting this comic.v, and this comic.v is coming from this one. So we are adding um, a field, temporary field here, and this one is using the logic that from the lookup, when we say comics, it will be an array, but we know there will be many to one relationship. Basically, there will be many superheroes that are using one comic. So we know it's going to be one comic that we'll get. So although it is an array, but we are interested only in the first index. So we get that one, we call it comic, and from comic, eventually we create this comic.v, we create the field comic that will be used for our output, and this is what we have here on line number 12. So this is the comic field name that we are trying to create over there. So all that setup will help us to find the data and bring the data from comic into superhero, and result will be returned. So now we are calling connect to MongoDB, our local function, to get the client object, and then we are getting the heroes collection. So this is the heroes collection variable. And next, using all those doc macro that we used above to load lookup from comic table, we have to use the pipeline concept, this like aggregate in MongoDB, and we are putting this load hero comic. So all these that were listed in the top, we have to include all of them. One important thing, and I have this comment up here, is that this first collection item only, the one where we read the first element from the array, it has to come at the bottom. If I move it before add first, this whole thing is not gonna work. I don't know what's the reason for this sequencing. Like if I look at the MongoDB documentation, there is no such requirement, but I don't know if it is because the Rust driver or whatever the issue is. This is how it works. I cannot swap at least these two lines, line number 89 or line number 90. They have to be in this order. So once we have created the pipeline, and we have the heroes collection, we call aggregate past the pipeline, and it will return as a cursor. So since we are not filtering on any hero, so we said just give me all heroes from that collection. So it will just go and grab all of them. We create our uh, return value, superhero result or DTO. So we have that object, and now we have this cursor that is pointing to the MongoDB database. So we call next, that will give us the next value from the actual database, and we call based on format from document. So this will convert the document into superhero result. And since we already added that comic field, now it knows uh, how to serialize data from the document to this object, and then we just keep adding into our vector before we return the data. As I left this comment, it will be helpful for me and also for others that are looking into this source code. We can use future crate, and there are different ways to get the data. Um, so I think only issue was because reference data that was not working. So all this is I put the document, and also I documented all that and also put the link. But that was the alternate method. That's why I had the feature reference added into stream. Next, look at the single hero handler. Let's do it quickly because most of the things will be same. So here, one difference is previously we just had the lookup because we are getting all the heroes, but now we want a specific hero. So we are saying match. So this is again MongoDB structure. So match, we use a doc to create MongoDB specific document structure, and say hero name, where hero name is I'm using the regex. So this regular expression um, will help to convert the secret ID that we're passing on the client side, like say Superman or Spider-Man, to make it case insensitive. So this option I is case insensitive. So we are saying from the beginning to end, compare with that one, but case insensitive search. So this is important. And after that, everything else is same. We have the lookup, so we are getting the comic ID. And I mean, as you can see, maybe I can refactor the code later on, put them into same. some helper methods. So all these load hero comic, add first, all this is same as the all heroes. And then we build a pipeline exactly same, find hero, load hero comic. Again, the important thing was this line number 154, 155. They have to be in proper order. Um, and then we get the client connection to the MongoDB, get the heroes collection, and now we are calling this same hero collection dot aggregate. Since we have the find hero that match structure first, so it will try to find that one specific hero. And I mean, I can use if statement too here, but anyway, so cursor dot advance, and then we get we read the document. So we deserialize the content. There's a document, and it will convert to this object superhero res or result, and then we return the data. Otherwise, we return, if we cannot find, just return empty or none with the default. One thing, let's see. So I'm using advanced here, but if we go up, I was using cursor.next. So these are two different options. You can either use cursor.next as I have on over here at line number 100. So cursor.next, and you get some document, and then you can convert it. Or as I did down below here. So this is another option as per the document cursor.advance. So go to the next entry and then still use the deserialized current. So deserialized current versus you just get the document and then convert it. So these are the two options. I I don't know if one is preferred over the other, but yeah, so these are the two options. Add new hero is even actually simpler because searching was a little bit more complicated. For add, we get the superhero object and get the connection. After that, we convert the superhero object, we convert it into the BSON or document. So the serialized hero is created, and then from that document, we are calling collection.insert one, and document we pass it. Once it insert the data, we call the insert result dot inserted ID. Since object ID we are auto generating in there, so it will return the new ID that was just created, and I just return it back to the client that what was the new ID. Delete is similar to add. It's pretty simple. Just one method we have to call here, line number 210, find one and delete. So it will find and delete. So since in this case we don't have to worry about bringing the comic, so we don't have to use lookup, all of that thing. We just say find where hero name is, superhero ID or the superhero name. Where it finds it, it will delete it, and then we just return the message. So that's pretty much it for the API part, and we already saw the code from the front end. We are calling the actual API through the service, and these are the API endpoints that will be helping with it. So I have the code running. Yeah, I have the code running. So let's jump into the application. So in the application, now if I let's see. So if I do get data from server, so right now it just says it is started. So I say get data from server, and it returned only one object, Spider-Man. If we add a new superhero, Superman, and we can say DC, and if I hit save, we'll see some log. So here, as you saw, that we are returning the object ID for the new inserted element. So this is the ID. So we'll return it back to the client, and then I go back to superhero list, and if I do get data from server, now it will print all the names. As I showed in the UI, it was not required. I mean, I was just looping through that vector just to get the names. It was not required, but I'm just logging it. And also we can delete it. Yeah. Yeah. Let's see if I go and open another tab, and let's hit the 8080 and superhero. So if I call it directly, this is how it is returning the data. So we have the ID. So this is Spider-Man, and then we have I can zoom in a little bit. Okay, so we have that, and then we have Clark Kent, hero name, and we have comic ID, but also the actual ID of this object. So this is the ID for second entry. And oh yeah, so one thing that we cannot test, of course, from the UI because we don't have find specific. We have add and delete that we can test out. But if I want to look for a specific hero, let's say Spider-Man. So since we are doing type insensitive search, so although M is in uppercase, it will still try to find the Spider-Man. So it did the hero name case insensitive match and got the Spider-Man entry, and it will work for Superman as well. So that endpoint is working properly as well. If I delete this record, so let's see here, delete, or let's see it's on the MongoDB side first too. So if I go to MongoDB and here, if I right now it shows only one. If I do refresh, it should show now both. So we got the Superman and um, Peter Parker. So now if I go to the UI and try to delete Superman, so delete, okay. So we got the confirmation that it is deleted, Superman. Um, that was successful. We don't see it over here, but if we um, go back to our MongoDB, MongoDB Atlas UI, and do the refresh, now it only shows one entry. So it just confirmed that it's working as expected, and all the calls are going to actual database. Okay, so yeah, that was it for this series and this video. I hope you all enjoyed and it was useful. In my next series, I will try to build some end-to-end application. It may take a little bit longer to actually build that one because I will try to find some other WASM based app that either is done in the U or Blazor on the .NET side and try to create it in Rust, Dioxus, and Axum. But this time I'll try to match the UI and the feature so it looks as closer to the actual reference application that I will be using. So yeah, um, I will I will provide the links in the video description, and that is it. Thanks for watching, and I'll see you in the next one.